Hey everyone, this is Princess and welcome back to our channel. In this video, we will be diving into the exciting world of NFT AI minting using Hardhat. Okay, so first things first, let's create a folder here in our desktop and name it Minting AI NFT. There. And then inside this folder, let's create another folder and name it Hardhat. There, so here inside the Hardhat, this will be our working directory. This is where we will save all our files in one place. Okay, then we need to set up our development environment. So let's open our code editor. In my case, I will use the Visual Studio Code. And you can use any code editor of your choice. Just make sure you are inside the Hardhat folder. So let me just quickly navigate to the Hardhat folder. Okay, there. Also, make sure that you've already installed the Node.js and NPM in your computers for us to manage our project dependencies smoothly. Okay, so let's open the terminal, new terminal, and then I will use git bash. You can use PowerShell if you like. Then let's go to the Hardhat directory. And then once we're inside the Hardhat directory, we will initialize our folder. So to do this, just type npm init -- yes. Okay, so let's wait for a while. While it's it's done initializing the folder, we can see here that we now have a package.json file. So this is where we can see all the details, all the dependencies, list of dependencies that we will use for this project. Okay, so now let's proceed with the installation of Hardhat library. Just type in npm install -- save -dev space Hardhat, then click enter. So this installation may take some time, so you can go ahead and grab some coffee while waiting. So I'm gonna pause this video first and get back when the installation is complete, okay? Okay, now that my installation is complete, we can create a new Hardhat project, and we'll do this by running the following command, npx hardhat. In here, we will choose the option to create a JavaScript project. So just click enter, and then enter, yes, enter, and then enter. Okay, so in here, it says that we need to install this dependencies. Okay, so we finished installing the Hardhat and then the Nomic Foundation. Okay, so let's install the Nomic Foundation by issuing this command. So let's just wait for a while it's installing. Okay, there. Let's also install the other dependencies that are required for this project. Let's install the OpenZeppelin contracts. Okay, and then the next one that we will install is the .env. Okay, so we're done installing all the dependencies that we will need. You can also see here that the package.json is automatically updated. And we can see here the things that we've just installed, the .env, OpenZeppelin, the Hardhat, and the Nomic Foundation toolbox. Okay, so now that we're done with all the installations, we are now going to write the NFT smart contract. So this is where we will define the rules, features, and functionalities of our AI-generated NFTs. So navigate here through the folders on the left, and inside your contracts folder, we can delete this one. We don't need it, and then there, and then here we will create a new Solidity file and name it mynft.sol. Okay, so this is where we will write our smart contract. Okay, so the first thing that we will do is to declare the license identifier. So this specifies the license under which this code is released. MIT. Okay, then let's set the version of Solidity that this code is compatible with, the Pragma Solidity. Okay, so we indicated here that we will use starting from this version 8 up to the most recent one. Next, let's import 3 contracts from OpenZeppelin. So the OpenZeppelin is basically a company that writes smart contracts based on the ERC standards, which are already audited so many times. So if you want to dive in OpenZeppelin, you can go to their official website. which we will put the link in the description box, and then you can see their documentation. So these imported contracts will serve as libraries and will provide essential features for our contract. The first one, the ERC-721 URI storage. This will provide the basic functionality for an ERC-721 that stores the token URI in a separate storage location. Okay, and then this ownable, this provides access control features. It provides basic ownership functionality. And then the last one is the counters. This will provide a way to keep track of a counter value in a more efficient way than using a regular valuable. Okay? And then now let's define our my token contract. So the contract, which is the keyword when you want to create a contract, followed by the my NFT, which is the name of our contract, and it matches the file name that we defined a while ago for proper naming convention and consistency purposes. Okay, and then let's also inherit from ERC-721 URI storage. There you go, which is a template for ERC-721 tokens with URI for each token and ownable, meaning it will be owned by a single address specified in the ownable contract. Okay, and then now let's create a using statement for the counters library. So this lets us use the functions from the counters library directly on the counters .counter data type. There. And now let's declare a private variable named token ID counter as a counters.counter. There. So this variable will be used to keep track of the next available token ID. After that, let's implement the constructor. So the constructors only run once, which is during the contract deployment. So let's call the constructor of ERC-721 and to initialize the contract with the name my first NFT and the symbol MFN. So there. Next, let's implement the SafeMint function. So this function allows the contract owner to safely mint an NFT and assign it to a specified address. Okay, so let's add two parameters, which are the address to parameter of the recipient, and then the string parameter URI or uniform resource identifier of the NFT. Let's also make it public and add the only owner modifier. Okay, now within the function, let's start by retrieving the current token ID from our counter using the token ID counter dot current, and then we will assign this value to the token ID variable of type uint256. There. Then we will increment the token ID counter using the token ID counter dot increment. Okay, so this ensures that each newly minted NFT receives a unique token ID. Okay, and then next, we will use the internal SafeMint function from ERC-721 to create the NFT and assign it to the specified address to with the generated token ID. Finally, we will set the token's URI using the setTokenURI function, and then we will pass the token ID and then the provided URI as argument. So this sets the metadata of our NFT, allowing it to be displayed and identified uniquely. Okay, so there, now that we've written our NFT smart contract, it's time to compile it. So compiling ensures that our code is error-free and is ready to be deployed. So let's go here to the terminal and issue the command npx hardhat compile. Okay, so let's just wait for a while to finish our project compiling. Okay, so it says that compiled 18 Solidity files successfully. It means that our NFT is taking shape, but before we deploy it, we need to configure the deployment script and Hardhat network settings. So to do that, let's first create a .env file inside the Hardhat folder. .env. Okay, so the .env enables us to save some confidential information that cannot be shared to the public when deployed. So this is where we will save our HTTP provider and our private key. So for my HTTP provider, I used the quick node, which is this side. So you can go ahead and visit their site. Also, if you want to use this one, you just have to sign up and verify your account to be able to create an endpoint. Okay, so let's set this here in our .env as quick node underscore http URL is equal to quotation marks. Okay, so then we will paste inside this quotation marks the HTTP URL or the HTTP provider that was given to us by QuickPoint. Okay, then we will also save our digital wallet's private key here in .env. In my case, I'm using MetaMask. So private keys are like secret codes that allow you to access or have access to your digital wallet. It's a combination of numbers and letters that you should never share to anyone. Okay, so let's save it as private key underscore key is equal to quotation marks. So you will paste your private keys here inside the quotation marks. And then don't forget to save. Okay, so now after saving all the necessary info on your .env, let's go ahead and open the deploy.js file inside the scripts folder. Okay, so we can delete this whole thing. And then let's begin by importing the necessary modules and configuring our environment. So first, let's require the Hardhat module and have HRE or the Hardhat runtime environment. And then let's also require the .env to read and manage environment variables from a .env file. So there. Now let's have an async function and name it main. Within the async main function, we use the await keyword to deploy the my NFT contract using Hardhat ethers that deploy contract. And inside this parenthesis, we will put here the name of our contract, which is the my NFT. There, and then the ethers.deploy contract method takes the name of the contract to deploy as an argument. So let's assign it to const my first NFT contract. So there you go. And after deploying the contract, we will wait for its deployment to complete using the await my first NFT contract dot wait for deployment method. Okay, so this will ensure that the contract is fully deployed and ready to be interacted with. Finally, let's print on the deployed my NFT contract to the console using the console log. Let's have here my first NFT contract address. And then the my first NFT contract.target. Now we will call the main function to execute the deployment process. So if the deployment is successful, it will exit with code 0. Otherwise, if there's an error, we print the error and exit with code 1. Okay? So this returns a promise. So we use the dot then and catch to handle the outcome. So if the main function succeeds, the then handler will be executed. Otherwise, if the main function fails, the catch handler will be executed. Okay, so let's click Ctrl S to save. So we are done with our deployment code. And by running this code, we'll have our NFT contract deployed and ready to mint unique tokens. Now let's go to hardhat config.js file, which is this one. And then let's also... no, let's not delete this. Let's just add the .env to manage environment variables. Let me just copy from the deploy.js that we did a while ago. There. So the hardhat.config.js file is where we will define the Solidity version, various network configurations, and more. So in this video, I will connect our Solidity smart contracts to the Mumbai test network using a private key. So this setup will enable us to deploy and test our contracts seamlessly. Okay, so now we've imported the required dependencies, which are the Hardhat toolbox and then the .env. And then let's also retrieve the values of the environment variables, which are the quick node underscore HTTP underscore URL, and then the private key. There, so we will use the process.env to retrieve the values of these two variables. Let me just copy this. Same with this one. And then let's add const here. So there, the quick node HTTP URL will hold the HTTP URL of the Mumbai test network we want to connect to, and then the private key variable will store our private key for account management. Okay, so now that we define the Hardhat configuration object that we will be exported to manage our project settings. So we have here Solidity. Let's put in 0.8.4. I think that's good. And then let's define the network that we will be using to deploy. Okay, so in this case, let's use the Mumbai, which is the Mumbai test network. And then let's specify the URL of the Mumbai test network as quick node HTTP URL. Then let's provide the private key variable to indicate or to know the account that we will use to deploy and interact with our smart contract. Have here private key. Okay, so there, don't forget to always click save or Control S to save. And then that's it, Hardhat configuration script that connects our Solidity smart contract to the Mumbai test network using the private key. Okay, now here comes the big moment. So it's time to deploy and verify our smart contract. So to deploy our contract, let me just compile it again first, just to make sure that we have no more errors. So let's just wait for a while. Okay, so there are no more errors and our contract is ready to be deployed. So to deploy, let's issue the command npx hardhat run scripts/deploy.js and then -- network. And then since I'm using Mumbai, I will type in Mumbai. So if you're using a different one, just replace it with the network name that you are using. Okay, so let's wait for it to be deployed successfully. In here, I think we should see the contract address to be displayed here in our console log. Okay, and there you go. Our NFT contract address is this one. So let's copy this. Control C. Oh, I'm sorry. So let's copy this. And then I'm gonna close this one first. Let's put it here in our contract as a comment and click save. Okay, so we're almost there. And then since we've successfully deployed our smart contract, let's now verify it to be able to mint an AI NFT using Hardhat. So just type in your terminal npx hardhat verify network and then Mumbai. Paste the deployed my NFT contract address, which is this one. So let's copy this and then paste it here. Enter. Okay, it says that we've successfully verified our contract and we can see it here in our block explorer. So since we are done with our code, what's the point of all of this if we can see it in action, right? So let's mint our first NFT. We can click this one, control click, or we can just go to Polygon scan. Okay, control click this one. Click open. Okay, so here in the Polygon scan. So verifying our smart contract on Polygon scan provides a solid proof that the code behind our NFT AI creations is legit and transparent. And when you verify a smart contract, it allows the developers or the users to trust and engage with your NFTs. So let's try to mint an NFT using a Polygon scan. Okay, so let's go here in the right contract tab. So the check mark here also indicates that your contract is already verified. Okay, so let's connect first to Web3. Click MetaMask since I'm using MetaMask. Okay, now I am connected to my wallet. So let's click the Safe Mint function right here since this is the only one that we will use. The other functions here are from the inherited smart contracts that we imported earlier. Okay, so here let's paste our wallet address. Let me paste mine. And in here, the URI string, we will paste here the metadata of our NFTs. So I will use the pre-generated metadata files for my NFT project. And then this contains JSON files that has the important information about our NFTs, such as its name, description, and other attributes. So let me paste it here and then click write. So the MetaMask should pop up to confirm our transaction. And then to view the minted NFT, we will go to OpenSea. So we will use the testnets.opensea.io. Make sure that you are connected to your wallet. Just click here for the profile. Okay, here, so we just minted a Hawkeye's longbow. Just click this image and we can see here the different traits this image has. You can also click this image to view the different details. We have the description, the traits, the levels, and then some details about it. We have the contract address and then token ID, the standard, the chain, and then when it was last updated. So we just minted this 37 seconds ago. So the different details or data about your NFT can be seen or can be edited in the metadata of your NFTs. Okay, so it's just taking so long to load. I don't know why, but basically that's it. We've gone through the thrilling process of NFT AI minting using Hardhat. So from setting up our development environment to writing the NFT smart contract, deploying it, verifying it, and minting our very first NFT generated by AI and minting it using Hardhat. I don't know why it's taking so long to load, but let's try to mint another one. Let's have this. And then let's confirm the transaction in our MetaMask wallet. And then let's view our transaction, or let's check it in our OpenSea account. And there you go. It loaded quickly. I don't know why the other one is loading so slow, but this one, we've successfully minted an NFT generated by AI. So we have here the details of our NFT. We have the description, traits, levels, details, the contract address, token ID, token standard, Bombay, and then last updated in 2 minutes. Okay, so there you go. We've successfully minted an AI-generated NFT.